Hello dear friends, in this section, we will talk about how to install Docker on Windows. This section explains the installation guide on Windows and Mac operating systems. First, we select and download the desired installation file. The following describes other requirements. Next, open PowerShell and install the required requirements. Enter the command you see in the image in PowerShell and run it. Next, go to the Docker website and download and install the Windows version. The installation process is very simple and there is nothing special. After installing the Docker desktop version, open it. Now you see the Docker software environment in the image. Let's talk about the important concepts of Docker. Docker has 4 important parts. First, let's talk about the Docker engine and this part of Docker. Docker engine is the runtime management layer that turns Docker commands into real, running containers. It's the piece that pulls images, builds images, starts/stops containers, wires up networking, and attaches storage, all by using OS-level isolation features. Docker engine is made of 3 components. 1. Docker CLI, Docker, the command you type, Docker run, Docker build, Docker PS. It doesn't run containers itself, it sends requests to the daemon. 2. Docker daemon, Dockered, the long-running background service that does the work. It exposes an API, REST over a Unix socket on Linux/macOS, or a named pipe on Windows. It manages images, pull, tag, remove, containers, create, start, stop, restart, networks, bridge/overlay, DNS, port publishing, volumes, create, attach, garbage collect, logs, and events. 3. Container runtime stack, typically containered runc, containered, manages container lifecycle at a lower level, image store, snapshots, running tasks. Runc actually creates the container process using Linux primitives, namespaces/scripts, following the OCI spec. Think, Dockered is the manager, containered is the execution service, runc is the process spawner. Docker Desktop is an all-in-one app for running Docker on Windows and Mac OS, and also available on Linux, that bundles Docker's core components and makes them easy to install, update, and manage. Under the hood, it runs Docker engine in a lightweight Linux environment, typically WSL2 on Windows or a small Linux VM on Mac OS/Windows, so you can build and run Linux containers locally. What Docker Desktop provides: Docker engine CLI, so Docker build/run/ps work, Docker Compose, for multi-container apps via Docker Compose Up, a GUI dashboard to view containers/images/volumes, see logs, start/stop things, and monitor resources, easy setup for networking, file sharing, mounting local folders into containers, and proxies/certificates, optional features like a built-in Kubernetes cluster, depending on version/settings, extensions, and automatic updates. Key difference: Docker engine equals the runtime service that actually runs containers. Docker Desktop equals the package developer experience that installs/operates Docker engine for you. Docker Hub is an online registry service where people and companies store, share, and download Docker images. Think of it like GitHub for container images. You can pull ready-made images, like Jinx, Redis, Postgres, to run containers, and you can push your own images so others, or your team, can use them. What you typically use it for: find images, official images, and publisher images you can trust more than random uploads. Pull images to your machine, e.g. Docker pull Jinx. Latest, push your own images, e.g. Docker push your name/urap 1.0, versioning with tags, latest, 1.25, Alpine, etc. repos access control, public or private image repositories, org/team accounts, depending on plan, extras, vary by plan, automated builds, security scanning, webhooks/integrations. In short, Docker Hub is the default place Docker pulls images from when you run something like Docker run Jinx, unless you specify a different registry. Docker Compose is a tool for defining and running multi-container applications as one project. Instead of starting containers one by one with long Docker run commands, you write a single docker compose.yml file that describes your services, e.g., web app, database, cache, their images/build instructions, environment variables, ports, networks, and volumes. Then you run them together with commands like docker compose up and stop them with docker compose down. What it's used for: run an app dependencies locally, Laravel Jinx PHP FPM MySQL, etc. Keep configuration versioned in one file, create isolated networks and persistent volumes automatically, scale services, basic, and manage logs easily. Kubernetes, often called Kubernetes, is an open-source system for running and managing containerized applications at scale. If Docker runs containers on one machine, Kubernetes runs containers across many machines, a cluster, and handles the hard parts automatically. It schedules containers onto available servers, keeps the desired number of instances running, self-healing, scales up/down based on load, rolls out updates with minimal downtime, provides service discovery and load balancing, and manages configuration/secrets and storage. You describe what you want, for example, run 3 replicas of my API, expose it on a stable endpoint, update with 0 downtime, and Kubernetes continuously works to maintain that state even if containers or servers fail. Enough talking about Docker concepts. Next session we are going to look at an example together. See you next session.